Hello friends, welcome to my channel. Let's have a look at problem 1652, Defuse the Bomb. In this video, we are going to share solutions based on sliding window, and we are going to share two formats of solutions. First, I will read through the problem statement to digest the requirements. Then we do the analysis and share the codes. First, let's look at the problem statement. We have a bomb to defuse, and our time is running out. Our informer will provide us with a circular array code of length n and a key. To decrypt the code, we must replace every number. All the numbers are replaced simultaneously. So first, if k is greater than 0, so replace the ith number with the sum of the next key numbers. And if k is less than 0, replace the ith number with the sum of the previous key numbers. And if k equals 0, replace the ith number with 0. So as code is circular, the next element of code n-1 is code 0, and the previous element of code 0 is code n-1. So given the circular array code and an integer key, return the decrypted code to defuse the bomb. So here are three examples. So example 2 is the easy case because k equals 0. We just need to return a result of length 4 with all elements being 0. So let's look at example 1. So for example, at index 0, so we're going to return the sum of 714, right? So at index 1, so we're going to return the sum of 145, right? That is 10. So similarly, you can interpret 16, 13. So this is example 1. For example 3, so the k is negative. So for index 0, so we return the sum of 9 and 3, that is 12. And for index 1, we're going to return 2 and 3. Their sum is 5. And you can interpret 6 and 13 similarly. So before we do the analysis, let's look at the constraints. So first, the length of this list is less than or equal to 100. So this is not very large. So we have a lot of freedom to do whatever we feel natural. So next, we are ready to do the analysis. So as we mentioned, we are going to use sliding window. So here is a remark. So this problem is very straightforward. However, it's important to pay attention to the indexing for this problem. So first, I'm going to pick up this case k equals 0. So this is easy. So we just ignore that. So for k is greater than 0, as in example 1, for example, the code is here and k equals 3. So we are going to append the code with this key elements. So for example, this is the original code, and then append these 3 elements. And then we do sliding window backwards, right? So let's see, for k is greater than, so this is the like this. So for example, we initialize a result, and then so result 3. So we are going to have the corresponding number is 5 plus 7 plus 1, that is 13. And then for index 2, so we are going to sum 4, 5, and 7, right? So this number is nothing but the previous sum, so we ignore the 1 and add the 4, that is 16. Then for index 1, so what we are going to do is that we use this 16, then include this 1 and minus the 7, right, the previous one, that is 10. Then at index 0, so we are going to include this 7, but ignore the 5, so we get 12. So this is the case when k is greater than 0. So when k is less than 0, so as in example 3, so the code is here and k is negative 2. So we are going to append the following 2 elements in the front. So this is then 3, right? This is the original code. And then we do sliding window forwards, right? So for example, result 0 will be the sum of these two numbers, and result 1 will be the sum of this 3 and 2, right? And result 2 will be the sum of these two numbers, and the result 3 will be the sum of these two numbers. That's it. So with that said, so we are ready to present the code. So in the first version, I'm going to follow through this one. So we are going to use this sliding window and to save some computations. So basically, we do not want to do slicing using a segment of length k. So first, let me get the length information of the code. So this is the original length, right? So first, I'm going to treat the case when k equals 0. So when k equals 0, we just need to return an array or a list of length n with all elements being 0. So this is the one special case. Next, we are going to treat the generic case. So first, I'm going to initialize a result to hold the elements. Then we just need to set the corresponding values for the result variable. So first, I'm going to consider the case when k is greater than 0, right? So for this, we're going to append this code with code first k elements, right? And then we are going to do a sliding window in a backwards fashion. So for I in range n minus 1, -1, -1, right? So first, I'm going to treat the case when I equals n minus 1. That is the edge case, right? So we're going to do this. Result I will be the sum of code I plus 1 to the end, right? And then in the other case, so we just need to do this, right? So we're going to start from this window, and then we include the code at index I plus 1, and then minus the code at I plus 1 plus k. So this is the set for the k greater than 0 case. So we just need to return this result. So you can write here, or you can write a full return result for the case k greater than 0 and k less than 0. But now let's first do this return. And then what we are going to do is that we consider the case when k is less than 0, right? So in this case, so we're going to append the k elements, so in front. So here I'm going to use last k elements. So notice that k is less than 0, right? So plus code, and then we are going to do sliding window in a forward fashion. So for I in range n. So for this case, so we're going to set this result to be the sum of code, the first k element. So that is up to negative k, because k is negative, right? Otherwise, so here this is for if I equals 0, right? Otherwise, what we're going to do is to do this in a forward fashion, because result I minus 1 is already set, and then we're going to include this number. We want to exclude this number and include this one, and because k is less than 0, so this include this one, and minus code I minus 1, right? So let me see. So this is the result, right? So this is the element in the corresponding position in the appended code, and minus I minus 1. That's right. So with that said, we can do the return, right? So notice that we write two returns. One is here, one is here. So or if we can write here, so we just need to write one return. So with that said, we are finishing a solution format. So now let's look at the test. Yeah, it passes an example. Now let's look at the generic case. Yeah, it passes all the generic cases in a fast fashion. So this is the one solution format, which basically we optimized the length of the code we are working on, like here and here. However, notice that in this problem, the length is bounded above by 100. So actually just need to double the code and then do the coding. So let me copy this function signature and then put it here, write another solution format. So I'll call this one V1. So solution V1 will be actually more efficient in some sense than solution V2. So we're going to use this one. So for this, I'm going to initialize so let me first get n. N is the length of the code list. And then what we are going to do is that we'll make a list to double the code. This way we can take the circular structure, right? And then we just need to set for the corresponding position in the result. That is for I in range m. So what we are going to do, let's see. First, if k equals 0, so we just result I equals set to be 0. Otherwise, if k is greater than 0, so we just do something in a brute force fashion, right? We just need to sum, so list, so from I plus 1, and then we use k elements, so this is the one. Otherwise, the k is less than 0, so we are going to set this like sum, so not list, so here is lst, so lst, so we're going to do this I plus n plus k, right? So up to, let's see, I plus length code. Let's do the n, right? I plus n, and so notice that this from here to here, the difference is k, as is negative k, right? Negative k is positive, so there are k elements. So then we are going to return the result. So notice that in this version, we are using sliding window, but it just computed the sum in a very brute force fashion compared with version 1. So with that said, we are ready to do a test. Yeah, it passes a special case. Now let's look at the generic case. Yeah, it passes all the generic cases. So with that done, I guess that's about it for solutions to this specific problem. So here we emphasize solution V1 because here we just need to do the sliding window in a more delicate way. But here the important thing is that we need to pay attention to the indexing, right? Besides this, the problem logic is rather straightforward. With that said, I guess that's about it for this video. Thank you.